In today's world, energy usage is a big topic as we look for more sustainable energy options to lower our carbon footprint and mitigate climate change. Today's presentation will show how a thin film dryer sustainably fits into the energy and heat flow for common drying processes, with and without anaerobic digestion. Having a highly efficient dryer is an important first step to help minimize our carbon footprint. Typical dryers have a heat usage up to 1600 BTU per pound of evaporated water. To achieve the greatest efficiencies, these dryers must use the recovered waste heat for the drying process. On the other hand, thin film dryers only require as little as 1150 BTU per pound of water evaporated. This is up to 30% lower than other dryers. Additionally, the recovered heat can be used for other processes. The thin film dryer's efficiency can significantly lower the climate impact of your biosolids project. First, let's look at the historical way to heat a dryer with natural gas. The thin film dryer has an advantage in energy usage, 1200 BTU per pound of water, compared to 1300 BTU per pound of water for a typical dryer. The process on the left shows the typical dryer, where all the natural gas is used to heat the dryer, and that heat is lost or it is used to improve the efficiency of the dryer. Contrast this to the thin film dryer on the right, where up to 85% of heat can be recovered. The heat lost from the thin film dryer is only 344 BTU per pound of evaporated water, compared to 1480 BTU per pound of evaporated water with a typical dryer. This makes heat lost from the thin film dryer about 1/4 of a typical dryer, which is a huge decrease in energy consumed and greenhouse gases emitted. Anaerobic digesters have been a great source of energy for decades, and over the years, the biogas has been put into useful processes. At first, and with many applications still today, the biogas is flared, losing all the energy to the atmosphere. Then processes arrived and the biogas was made useful by heating the digester and/or dryer, creating an energy loop. But the process stopped here and waste heat from the dryer could not be used. Then an extra step was put into place with combined power and heat, or microturbine system, to generate electricity and heat from the biogas. Low-temperature belt dryers, for example, were designed to use waste heat from this process to dry sludge. But the process stopped there. Waste heat from the dryer could not be used for additional processes. When using the thin film dryer with biogas from anaerobic digestion, the dryer can be directly heated by the biogas. It can create waste heat at a temperature to heat the digester, creating an almost complete energy loop with little wasted heat through the drying process. The key in this process is rethinking where the dryer is located, not at the end of the heat process with low temperature heat, but in the middle of the heat process with higher temperature heat. Today, incentives have made biogas profitable as renewable natural gas. Many producers of biogas are selling the biogas and purchasing natural gas for heating. In this case, the thin film dryer makes perfect sense. Natural gas can be used to heat the thin film dryer. The waste heat from the dryer is used to help heat the digester, lowering the amount of natural gas burn. Most of the drying energy is completing an energy loop in place of being used to only dry the sludge. Thank you for watching our presentation. The thin film dryer, when integrated properly into drying or anaerobic digestion with drying applications, can save a significant amount of energy. This helps combat climate change and reach energy goals. If you have any questions or would like to discuss your application in more detail, please reach out to our expert, Chip Pless, at the contact information listed. As always, please like, follow, and subscribe to our social media, and be on the lookout for more presentations from LCI.